Good evening and welcome everybody to our Insight Into this evening. I'm really pleased to welcome you all, even though it's remote and not live in person. It's lovely that you're all able to join us tonight, and it looks to be a really fascinating evening. And the theme of tonight, as you well know, is research, science and discovery, and it's such a huge area, and we're delighted to be able to welcome three very distinct specialists with us this evening. So we've got Sujata, who is Associate Scientific Project Leader at Helios Medical Communications, and we've got Kotska, who is the Earth Care Mission and Optical Payload Manager at European Space Agency, and we also have Professor Faydauka, who is Professor of Theoretical Physics at Imperial College London. So in a moment I'm going to introduce our first speaker. You may notice that there is a chat function or a conversation function at the side, and you're very welcome to post questions in there if you'd like. And we're also going to have a Q&A session at the very end with an opportunity to ask some questions there. After our three speakers have given their presentations, I'm also very delighted to be able to introduce to you Miss Hannon, who's our Head of Careers here at Manchester High, and she'll give a short presentation about routes into these careers from a sort of qualifications university point of view. So it's lovely to see you all here. I'm very delighted to be able to welcome all of our speakers. And without further ado, I'd like to introduce our first speaker, Sujata. So Sujata, over to you and welcome.
Hi everyone. Hopefully you can all hear me. Yeah, I just wanted to start by saying thank you to Man High for inviting me to speak. It's really, this is such a great initiative, and it's so nice to know. I think it's at least in its second year, if that's right. So yeah, such a valuable thing to be able to be a part of. So I am Sujata, as mentioned, and I'm an Associate Scientific Project Leader at Helios Medical Communications. Now, I understand that's probably a field not many of you have heard of, if any, so I will go into that a little bit more later. But yeah, I thought I'd kick off with a bit of a summary, if you like, of my time at Man High. So if we go to the next slide, please. So yeah, I think the easiest way probably to sum me up is a Man High girl through and through. So I started at the tender age of 4, nearly 5, because of when my birthday is, in 1994. I think that picture's actually probably a little bit later than that. I don't look like I'm 4 in that. And then I joined, that was in the prep, sorry, and then I joined the main school in 2001 in year 7, and I was in Miss Hannon's form. Little shout out there. And then again, you may recognise Miss Hannon in the picture on the right, striking an excellent pose, which is, I think, on our last day at senior 6, that was. So yeah, Miss Hannon had the pleasure of having Miss Hannon as my form tutor for 3 years, albeit not consecutively. So I think maybe if we go on to the next slide, I'll just give you a bit more of a breakdown of my sort of the second part of my time at school, which is obviously most relevant for you guys, I guess. So I had a very happy time in Man High, and when it got to year 9 and I had to start picking my GCSEs, to me it was always quite clear what I wanted to do, and it was never an option for me to not do 3 sciences, separate sciences. I really enjoyed them and I was good at them, and it was something that I could see myself doing into the future. So as well as the usual culprits, the maths, English, both English as French, etc. I took separate sciences, and I also took Latin, which may seem like a bit of a curveball, but you'll notice it's also in my A-levels, just because, you know, I wasn't necessarily thinking at that point even really about university and making a balanced CV or anything, but to me it was always just something a bit different, and I really enjoyed it and loved the teachers. Not sucking up here anymore, but yeah, Miss Hannah and Miss Wellesby really made it for me. So I took my GCSEs, and again, very much based on what I was good at and what I really enjoyed. It then came to selecting my A-levels in 2006, I guess it was. I at that point really had kind of standout subjects which I knew I really enjoyed, which were physics, maths and chemistry, not so much biology. Oddly, it never really clicked with me. And then I took Latin and French, at this point really thinking more about my personal statement and balance, but also again subjects which I enjoyed. So yeah, that involved Latin, and I took French AS as well, but unfortunately had to drop it after that due to timetabling conflicts. So yeah, I mean, again, along the bottom of the screen, there's a bit of a summary of my later years at Man High. So I think on the left, you've got one of our last days at GCSE, and then a few pictures from the last few days of A-level as well. I guess maybe you don't recognise all the teachers, I'm not sure they're there anymore, but Miss Wellesby is definitely right there in the middle. And yeah, again, Miss Hannon, I remember distinctly, and so distinctly, I found a picture of it on my phone the other day when I was making this presentation, a very lovely courgette cake, which was like a lot more delicious than it sounds as our leaving kind of gift for our form. So yeah, I got to the end of A-levels, or towards the end of A-levels, and started thinking obviously about what I wanted to do at university. And for me, the one standout subject that I could really see myself doing into the future and really loved was physics. So via a slightly circuitous route, I actually ended up applying for physics at a few universities and natural sciences at a few others. I'm not sure if you guys have necessarily heard of that at your level, but it's a degree which is not offered at all universities, but it allows you to explore multiple sciences in one go, if you like, and you can sort of tailor down your interests as you go. So I applied to Durham and Cambridge, definitely for natural sciences, because they didn't do single sciences, and to Manchester and Bristol and Birmingham, I believe, for pure physics. And to cut a very long story short, I got my A-level results and got into where I got into, and I ended up going to Durham to do natural sciences. But within a few weeks of starting the degree course, I realised that it wasn't necessarily what I wanted to do anymore. I didn't have the drive to complete a degree that involved so many different aspects. And to me, the clearest point was that I really wanted to do physics. So as I mentioned, Durham didn't necessarily do a pure physics course. And I started thinking about my options, and Manchester was my second choice when I had to submit preferences to UCAS. So I reached out to them, I think in my second week at Durham, and basically said, look, this is where I'm at. Is there any chance you'd still look to take me? And at this point, I think lectures had already started at Manchester, because Durham is very much like Oxbridge in that they start a little bit later than some of the other courses. So I was very lucky that they basically said, yes, great, we're still looking for students and we would love to have you. And I think at that point, physics was probably a bit less, I don't want to say glamorous, because it's not really glamorous now, but you know, it's maybe a little bit less desirable a degree to do. And I think probably Brian Cox and the like have made it a bit more cool in the recent years. But yes, so anyway, long story short, I ended up going to Manchester to do a physics with astrophysics degree. So maybe a good point to move to the next slide, please. Thank you. So yes, I started up a 4-year undergraduate master's degree, which came out as an MPhys at the University of Manchester. And my main kind of learning from this slide is not the various social activities you can see me involved in here, but actually more just the balance. You know, university is not just hardcore lectures, even with a subject as difficult and involved as physics. And there is a great balance, and you meet some great people, and it's not something that you should necessarily be afraid of. And let's say it's an experience that everybody should be exposed to. So yeah, just to summarize the time, really, it was 4 years of very intensive work. I think the contact hours for physics are probably higher than a lot of other degrees. And you can, so I think probably bottom right, but one, is a picture of a clock in the front, I think like the entryway of the Schuster building, which is the main physics building at Manchester, with a clock that you probably can't see very well, but it says 9, and that's 9 PM, not 9 AM. So that was a particularly long lab day we had, my lab partner and I, in final year. And I think probably the other thing to note is that MPhils, undergraduate masters, is not exactly the same as an MSc, where you do a bachelor's and then a master's. The main difference being that you don't graduate between the two, but also there are a couple of differences, at least with the course at Manchester, one of which being that you had a lab partner for your final year project, which most MSc projects don't have. So yeah, you kind of share the load a little bit, but obviously come out with very distinct results. Funnily enough, my lab partner, who you will spot at the top right here, may be a familiar face to some of the teachers here at least, was Annabelle Williams, who actually also went to Man High in the same year as me. She was in M. I was in G, so we were naturally pitted against each other, and we weren't necessarily that close at school, but we became very good friends at university because we ended up on the same degree, and I'm actually a bridesmaid at her wedding next year. So yeah, it's just another link that Man High gives you in life. So sorry, the quote at the top of the page as well is also related to me and Annabelle when we went on a night out and ended up being sort of accused of not being truthful when we said we were physicists, because apparently we didn't fit the exact role of a physicist. And there is a little picture of Brian Cox there in the middle as well, just, you know, claim to fame. So yeah, maybe we can move on to the next slide then. So next came the decision of what to do after university. For me, I got to the end of my 4-year degree and was very much in a position of, I don't know that I want to do the typical physicist thing, which I'm not sure if it still is, but certainly at the time, a large proportion of people went either into finance and banking or a very selective field of law called patent law, patent attorney. So I started to investigate some other options. I went to lots of careers fairs, and something that piqued my interest was the thought of further study. So I started to think about what I was interested in specifically within the field, and I had done a course in my final year which was called The Physics of Medical Imaging, which sounds slightly terrifying, but was really kind of gripping in a way that I hadn't felt about my other specific modules at university, because well, I think the primary reason being because I could see the applications of it in the real world. So we're talking about MRIs and PET scans. I'm not sure how familiar that term is to everyone, but positron emission tomography. It's used a lot in cancer imaging in the clinic, and CTs, all that kind of thing as well. So I started exploring my options there and found a PhD program at the University of Manchester, which I thought looked really interesting. So I reached out to the supervisor, the main supervisor for the project, and set up a bit of a casual chat, after which I was like, okay, this is something I really want to go for. So I applied, and again, long story short, got the PhD after an interview, and took up my PhD at the Wolfson Molecular Imaging Centre, which is part of the University of Manchester. And some of you may recognise the building at the top left there, which is next to the Christie in Withington. So it's a dedicated molecular imaging centre, to the point where basically the whole building is self-contained. Like, the basement is where we develop the materials we use to scan, and the ground floor is clinical imaging facility. The first floor is sort of offices where people do their research really, and the top floor is wet labs, so for preclinical work and things like that as well. So I had a very intensive but really enjoyable experience at PhD. Again, a lot of these pictures are a bit abstract, but kind of just represent my time at university. I was lucky enough, at PhD level, and I was lucky enough to go to lots of conferences abroad. So there's pictures there from a very snowy area of France, from Amsterdam, from Finland. So yeah, it was really kind of great, broad experience, life-wise, but also very focused on this really specific area of science, really, which was imaging of neuroinflammation. So yeah, I won't go too much into the science because I'm sure it is a fairly abstract concept at the moment for you guys, but basically I really enjoyed my time at PhD, and yes, it was very hard work, and there were points where I thought, oh gosh, what am I doing? You know, is this something that I see myself doing for a long time in the future? And I mean, maybe even then I had some doubts, but for me, the end goal was always get the thesis done and get to the point where you are happy and proud of what you're submitting. So yeah, I think, well, yeah, the only other thing to note there is that I made some very good friends at PhD level and still in contact with most of them. And you really do experience that together. You know, you're going through something that's really quite life-changing together. So it's always important to remember the support you can get from the people around you who are in the same position. So thanks, Lex. So yes, after my PhD, that's me submitting my thesis at the printers. So sorry, having just collected it from the printers, about to submit. And then if you go to the next, that's me on graduation day with my family, who I credit a lot of my life successes to. So yeah. Then following PhD, I moved on to a postdoc. Now, maybe I should have listened to my queries already in my mind at that point about whether I wanted to stay in that field or not, but I didn't. And there was lots of reasons behind that, but one of them being that I really wanted to explore more about the specific field I was in, and I was lucky enough to do my PhD in collaboration with industry partner, who were doing other studies in the field, one of which was based at Imperial College in London. So needless to say, I took up a job as a postdoc with them, and I moved to London in 2016. And after many years in Manchester, as you've now worked out, I'm sure. So yeah, I mean, I won't talk too much about this, but the time at Imperial really allowed me to develop, as a scientist, I was allowed to do a lot of independent work, more so than at PhD, I would say. But there was also a level of pressure that wasn't there at PhD, or perhaps I haven't felt at PhD, which involved, you know, if you're thinking about a long-term career in academia, you have to start thinking about this kind of thing, which is, you need to be thinking about grant writing and how you're going to keep your place and not just level off at postdoc level, which you can do for many years, but to become, you know, a professor, an expert in the field, which involves a lot of hard work, as I'm sure you will hear later in this session. But yeah, also perhaps an element of luck as well, and a drive that I at that point was not feeling. So although I had a lovely time at Imperial, again living in London, and met some great friends, I came to realise towards the end that I was not going to be staying in academia. So I ended up exploring other options, and this is where it comes to Medcoms. So this is where I am currently. I'm an associate scientific project lead at Helios Medcoms, and Medcoms is not something everyone's heard of, so I thought I'd just start with a quick summary. It's not just what you may have heard of as medical writing. It's not just writing papers for a company, basically, ghost writing almost. I think a lot of people see it as that, but it's not. Our main clients are actually pharmaceutical companies who need us to help them market their drugs, and they don't do this in-house for a variety of reasons, but agencies are a really important part of how they develop their drug. And yeah, I mean, these quotes are actually taken from some internal presentations we've had at Helios, but I guess that summarizes it very well. We develop materials that help educate healthcare professionals, or HCPs as we call them. There's lots of acronyms in Medcoms, about new technologies and innovations in medicine. So that can be drugs, or it can be technical devices and things as well. And we provide guidance and support to pharma companies on materials, including clinical trial publications and educational slide decks, but also congresses. Their presence at congresses and things as well. So yeah, broadly speaking, our field is about scientific data communication, and the form that takes is it's very varied. It depends on what kind of client you're working with. So we do product data, which can be clinical, preclinical, RWE, which is real world evidence, etc. And we do disease information, which can be very much with more so with the medical side of the pharma company, as opposed to the commercial marketing side, which comes into play when the drug has been approved. And then more broadly speaking, and I see more of this as I move up the company, I'm still fairly new, I only started in 2019. So yeah, we see strategy and tactics and planning by the pharma company for the future, what kind of message they want to send out to the world, and then non-drug information as well. So sort of patient adherence and general communication skills as well. So if you could move to the next slide. Sorry, I'm just aware of the time as well. So generally our audience in Medcoms is HCPs, so as I mentioned, healthcare professionals, but also investigators on clinical trials, whether they're associated with the pharma company or not, internal training, the general public, the media, and everything really in between. So yeah, it's quite a broad audience, and obviously when you receive a brief from the client, you're looking specifically at an audience that's already tailored. So you think about the language that you're using and things like that as well. So if we move to the next slide, this is just a lot of words, I imagine, to everybody, but oh yeah, there we are. So this is just a lot of words, as I say, but what is it really about? So my job is, as I say, it's not just medical writing. I actually ended up in a hybrid role at Helios, which it doesn't exist at every Medcoms company, but I very much spend the broad bulk of my day on project management. And also I highlighted teamwork here because it's not something that I experienced as a very heavily academic backgrounded person. You do a lot of solo work at PhD and postdoc level, and yeah, for me the biggest shock was finding out that I was working as part of a team, and how much I could come to rely on my team. So yeah, I've just put in a snip of my average day. So I might start a little bit earlier than I'm expected to. 9 to 5:30 is my working hours, but I start around 8:30 just so I get a bit of time to filter through my emails. And then I won't go through line by line, but my day is generally a bit of a mix of kind of internal catch-ups and meetings with my internal team who work on a specific account with me, and also client calls where we would discuss sort of upcoming or current projects and the status and what the next steps were. So yeah, sorry, I was probably running a bit over here. So yeah, the next thing I just wanted to talk about was what kind of experiences I've had and what kind of thing do we do day to day. I get the chance to go on site, or I used to get the chance to go on site, not so much anymore. So that means the kind of local visits at places where there are conferences or meetings going on which are being led by the pharma company. So I was lucky enough in my first year basically before the pandemic hit, to go to Bangkok and to Greece. And there's just some summary pictures of basically my time on site, which was very much not just drinking on rooftop bars, which is what it looks like. It was also extremely hard work, as I think is probably captured by the picture top right but one, which is my colleague and I sleeping in the back of a taxi on the way to the airport on the way home. So yeah, very intensive. And then if we move to the last slide, I think, oh, sorry, second to last slide. Yeah, so then just to cover off quickly, the pandemic hit, obviously beginning of last year, and you may think, oh, this is a field where, so much of it happens face-to-face, conferences happen face-to-face, meetings happen face-to-face, publications, all of this stuff needs face-to-face time. But actually, I'm really lucky to work in a field that has adapted so easily to the pandemic, and so much of it has gone virtual without really being a consideration. We were able to move immediately to home working, and obviously that involved a little bit of adjustment, lots of Zoom meetings, as you can see in the pictures. And also, yeah, the pandemic generally, I had an awkward hair growth phase. I used to have a pixie cut, not so much anymore. I got tech neck. My sister had a baby, so the pandemic was kind of frenetic time for everybody, lots of walks, lots of baking. But yeah, a bit of a balance, and work is still going on, and it's, if anything, busier than ever. So just to move to the next clip, we are now edging back into the office, and as I kind of hinted at briefly before, our company is actually doing so well that we've opened another office. So where I used to be based in Alderley Edge, I'm now based in Manchester city centre, in a new office which has its issues in that we didn't have bowls at the time this picture was taken, so that's me eating my fruit and fibre out of 2 cups because there weren't bowls in the kitchen yet, but there are now bowls. So yeah, it's been a bit of an adjustment, and I'm only back in maybe 2 days a week at the moment, but it's actually really nice to be able to work face to face with people who I have worked with previously, and also new people, because the company has expanded so rapidly. So yeah, just the final point, sorry, I'll stop waffling, just onto the last slide, is that I just wanted to make a note of kind of the thread of this entire story of my life, which is, very broadly speaking, the friends I made at school. So you'll see in the middle there, that's a picture from our Man reunion classes of, what were we, 2008? I think it was just class of 2008, the 08 years, 8 years. And yeah, those are some still very close friends of mine. But we've had lots of weddings, lots of 30th birthday celebrations, everything recently. And yeah, I'm just lucky to have kept in touch with so many friends I've made at school, and I think that's something Manhigh really breeds in their girls. So yeah, just wanted to make a note of that, and I'll stop talking now. Thanks.
So good evening, everyone. My name's Scott Squallis. I'm an engineer at the European Space Agency. Maybe if you could move on a slide or two. Okay, I joined Manchester High from moving into the UK from Australia. It was my 8th school. I'd actually missed quite a lot of school by then. I had Is it okay? Can you hear? Because I'm getting messages that you can't. It's good. Okay. Okay. Yeah, I moved to the school. I'd had a bit more than 6 months holiday, and when I moved to the UK, the teachers were on strike, so I had an even longer holiday. I joined the 2nd year of Manchester High, and I'd missed the first two terms, and I'd had a different first year. So I did my maths exam and I got 17%. I only knew Pythagoras' theorem, the only thing we'd done that term before the exams. So I had a lot of catching up to do. Manchester High was very accommodating. They let me skip doing Latin so that I could catch up all of the subjects. I already knew what I wanted to be at that age. I'd written to NASA when I was 11. I wanted to be an astronaut. It was quite clear in my mind. I watched sci-fi all the time, and that's where I wanted to be. We had a very good physics teacher at Manchester High, Mrs. Scarsbrook. She heard of this great thing called the First British Space School. She gave it to me, and I applied and got into British Space School. And so I could fulfill that first part of my trajectory, shall we say, where I met like-minded individuals such as myself interested in space, but I also got experience of the space industry, the companies who were contributing, and academia, the universities. So it was already clear to me where I could go. My GCSEs were, of course, kind of dictated by my desire to be an astronaut, so a rather standard set of sciencey GCSEs there. You can see I took Russian as well. Manchester High, at least at the time, had a language aptitude test, which I happened to do really well in. So Manchester High persuaded me to do Russian, even though I hadn't done the Latin. So I found it a bit challenging, but it was interesting to me because of the Russian space program. So I had a strong interest to follow up with the Russian. I didn't stay at Manchester High for my A-levels purely because I was living in Lymm and it was a long trip each day, so I couldn't join any of the teams. I couldn't do any of the team sports, so I moved to a different school. I moved to a boarding school, in fact, to do my A-levels. Again, they were heavily influenced by the requirements for being a payload specialist or a pilot astronaut. So the standard maths, physics, chemistry with computer studies. It wasn't all study, of course. I had an active social life. I loved horse riding. I learned to sail with Manchester High. I went to Tinebroek on the sailing camp, did my RYA certificate, and I still sail sometimes nowadays. I did Duke of Edinburgh bronze at Manchester High and gold at my next school. I think it's a great institution to follow up on the Duke of Edinburgh. I was in the Air Training Corps, and through the Air Training Corps, I learnt about flying scholarships with the RAF. They didn't take girls at the time. So I applied anyway, and luckily it was the first year that they accepted to have girls. I did 30 hours flying with them, and I needed then 10 more hours to get my private pilot's license. So you can see me flying in the top right-hand corner with a friend I made on the airfield, of course. He had a great toy box. It was a hangar with that Zlin in it. It's an aerobatic plane, and he had a couple of motorbikes. And he had a business flying aircraft back from airfield, so that allowed me to get my hours up and finish my PPL. As well as going on the first space school, I continued an association with them, and I worked as an assistant for several years. And in the end, this resulted in me getting an invitation to go to Russia with a bunch of other students. And that's why you can see me there. I'm actually in a Russian cosmonaut suit. I'm at Star City next to the pool where they train their cosmonauts. So if we move on to the next slide. Next slide is going to university. Because of my association with Space School, I already was strongly influenced by the universities that I wanted to go to. I knew which ones were doing missions that I found interesting. On the right-hand side, you can see Giotto. I'd visited University of Canterbury, and they were working on Giotto. Down at the bottom right, you can see it's a hypervelocity gun. They use it for shooting particles at plates, so it's simulating space debris hitting a satellite. Next to that, you can see the Huygens probe. They were working on that while I was at the university there. It's a probe that landed on Titan, next to Saturn. You can see Saturn in the background. So, I knew that this was a good university for working on space missions, and that's where I went to do my bachelor's. I chose physics with space science and systems there. Why did I choose physics and not engineering? I was advised that there was less maths in physics. I don't think that's actually a good advice. I think there's maths in physics and engineering. It's maybe slightly different maths. I think maybe I found the physics maths more esoteric. I think if you can do physics, you can do engineering and vice versa. Personally, I find that engineering, which is what I more work in now, is more like applied physics. I think they're both interesting topics. There's also some good courses in aeronautics and astronautics. For instance, at Southampton, some of the really good guys that I've worked with have done that course. I got to the end of my degree. I hadn't lined up a job. I hadn't done anything. And I only knew, to be honest, that I didn't want to do a PhD because I didn't want to spend another 3 years in academia. I wanted to go out and work. But I didn't have a job, and I knew that I could get this funded place on a master's course, and that was at UCL, University College London, which I knew of because I'd visited Mullard Space Science Laboratory, which is where that particular spacecraft technology and SATCOMs master's is based. And I did a thesis on tethers. You can see a tether being deployed from Space Shuttle there. It didn't work very well. They tend not to work very well. They're a great idea if we could just get them to work. The same with solar sails, another project I did. They're just very finicky, but a good idea if we can get them working. As well as studying at university, I was a part of the UK SEDS, UK Students for the Exploration and Development of Space. So that gave me more exposure to industry and possible future jobs. I was still sailing, that's down in the sailing team at the bottom. I was still keeping up my pilot's license, which meant that I was also working, barmaiding and dinner ladying, etc., and riding motorbikes. So I was having a good time. I've put International Space University on there because I did do a course with them. It was later while I was working. It's based at Strasbourg, but they hold a summer session for 9 weeks each year. And the particular session I went to was in Cleveland. It changes location every year. So next slide, please. So my first job, I had made it my business during my master's to make sure I had a job lined up for when I left. By now I had a good idea of where I wanted to go because I wanted to work on instrumentation. I wanted to work on satellites. I think I was the first person in my master's to line up a job. It was not a well-paid job. A lot of my colleagues went to jobs where they got higher pay, but they were mostly working in software, and it just wasn't something that interested me to work in software. I knew where I wanted to be at Defence Research Agency in their space department, because I had seen that they were building some small satellites there. Where I was actually placed was in the Geographical Information Systems part of Space Department, which was in a shed next to the Space Department. So I was their resident physicist because they needed someone who could do the physics for them. We worked a lot with synthetic aperture radar, a lot with remote sensing data from satellites, so I was working more on applications. You can see at the top there, it's an interferometric SAR image, so you can get centimetric changes there. You can measure those from space, and we were looking at, well, we were monitoring to see which countries were illegally testing atomic weapons. On the right-hand side, you can see an image of Gibraltar at the top, and it's the Straits of Gibraltar. You can see there's a big internal wave that you can see at the Straits all the time. It's the entrance to the Mediterranean. And you can see a sort of black splodge across there. That is a ship which is illegally cleaning its oil tanks, so something else we could detect from space. So as a really relatively young engineer, I found myself flying off to Gibraltar and speaking to the Coast Guard to get them to give us ground truth so we could see how well we could detect ships and identify which particular ships were doing what. So it was interesting work, but I knew I wanted to work in space instrumentation, so I had to go out. You have to go out and pursue these things yourself. So I went to the Space Department, the main building next door, and started chasing up other work. I got some bits of work doing constellation work, looking at constellation analysis. I was looking at the paint on tanks to see how well you'd be able to see them from satellites, which angle the satellite and sun would be, things like that. But I found someone I liked working for. He was also interested in building a small satellite with an optical instrument on board. We bought a telescope, took it apart to see if we could do it with a commercial telescope. It wasn't going to work, too much lubricants, too much cleaning and mounting of optics. So we bought some design software, and I started getting involved with optical design, with optical design software, and as part of designing the TopSat telescope. You can see a figure of it on the right there. And at the bottom, bottom right, you can see TopSat telescope. We called that the coffin. It's the engineering model of the telescope on a vibration table. We're checking to see it will survive launch. And just next to that, you can see the satellite. I didn't actually get to the end of that mission and see it launched because I left for my next job, which gave me great feelings of guilt because it was a great team, but it was an opportunity I couldn't miss when I moved to ESA. But you can see the mission did launch, and that's it. On the left, there's an image that was taken by TopSat. It's the Dartford Bridge. I continued doing space education-y type work. I got my sponsorship to International Space University. DRA paid for that, which kind of necessary because it's 9 weeks in a different country plus the tuition fee. And at the bottom, I'm wrapped in a flag, so I'm a Spice Girl representing the UK at ISU. I was also the UK representative educator at International Space Camp, which is held in the States each year. There is Space Camp, which anyone can go to. They have an international camp, which teachers from each country go to by invitation. So you can see at the top left, I'm in the multi-axis trainer. In the middle, I'm in a 6G chair, so I'm practicing how you would walk on the moon, ready for a moon mission. And in the bottom, I'm doing a mission, a simulated mission, wearing a spacesuit and 40 degrees in a hangar. It's extremely hot, and I'm wearing ice packs, filling my vest underneath because the spacesuit's very, very bulky. And I'm in a chair which simulates I'm floating in the chair, so it's on floaters, so it floats across the floor, and I can rotate it left and right, so I can do my spacewalk. Okay, next slide, please. So as I said, I saw this unmissable opportunity. I saw a job advertised for an optical engineer at the agency. I applied and got it. So I moved over to Europe in 2002, beginning 2002. And I was employed into the technical directorate, so I was supporting missions as an optical engineer expert, and I was developing new technologies for future missions. So on the far left, you can see Fluid Science Lab. I was involved in developing the optics for that, mainly the test of those optics. Fluid Science Lab's been flying on space station the last decade or so. It's probably come down soon because it's at the end of its life, really. Micro mirror arrays, you'll see, you probably don't know you've been seeing them, but they're used for digital protection nowadays in cinemas. The top left is a micropore optic, which we're using for focusing X-rays. You can see it then mounted in the telescope structure, and you can see a finite element model. So we're checking that it would survive launch, that the mounts would survive, the glass would survive. That's now on its way to Mercury on the Bepi-Colombo mission. And by the way, those are being looked at for use for medical imaging, because you can not put so many X-rays into a body if you use those X-ray optics. And to the right, there's a silicon pore optic, which will be part of the Athena telescope, which you can see top right. It's very big. It's a 3-meter aperture, sort of the follow-on from James Webb Telescope. So I was doing lots of different technologies there, but I was offered in 2008 the opportunity to become the principal engineer for the broadband radiometer on a new mission coming up called EarthCare. Well, you can see me down at the bottom left at the kick-off with the team for EarthCare in industry. That's in Bristol in TAS, UK. There's one lady next to me. She's the contracts officer at TAS, and all the rest are guys. I must say that is quite typical. It's getting a bit better. We do have more ladies now, but it is pretty well male dominated in the industry. But it's not been a problem for me ever. As well as you are doing your work and competent, then I have never had a problem. I carried on as the broadband radiometer engineer and also took on the multispectral imager. A few years later, I had the opportunity to apply to become the optical payload manager, which I took. That's a full application because it's a managerial position, so it means you have to do a full leadership competency assessment and a board of 4 interview, etc. So that meant I also had responsibility for the atmospheric LiDAR. You can see that I'm wearing the lovely hairnets. I'm in the clean room there with Atlid. And in the last year or two, I've taken on the mission aspects. So that means the ground segment. We also have a Japanese instrument on the top there. It's a radar. So we have a Japanese ground segment. The performance of the mission. Are we meeting the performance requirements, and the communications with the scientists who want the mission, of course. So I'm hoping that we get to launch that in 2023. And for my outlook on the rest of my career, well, I like working on instrumentation. So I'm quite happy doing this job, and I would look at working on the next mission, which I quite possibly hope would be the Athena mission, top right. I still keep my hand in a bit with the X-ray optics. Maybe to say that although I've always been quite, space, I did have other options. I always had backup plans. I would have been happy being a pilot. I would have been happy. I'm of course not an astronaut, so I haven't reached my main objective, but I am very happy in my career. It's very interesting and exciting. But I also applied to be a mounted policeman. I would have been quite happy in the mounted police. It's just that I felt that it was kind of wasting several years of degree work to go into that. So maybe the next slide. My typical day, there isn't really a typical day. It's a bit weird the last 2 years, because of COVID. It's been a big problem for us. We've had to try and get special permissions to get teams in from Japan to mount items on satellites. It's been very difficult. But a lot of what I'm doing is firefighting. However many mitigations and backup plans we have, we always have new problems and emergencies going on. So I'm consulting with experts and trying to solve technical problems quite a lot. I do review and assess a lot of technical documentation, a lot of procedures and proposals, justifications for why something isn't working, or justifications for why we can accept it not working, test reports and analysis. I have a team now, so I have a team of instrument engineers, processor and performance engineers for getting the data down and processing it. Ground segment, all the ground segment is under me, so all of that under the software engineers, the architecture and the software. And then the validation engineers for making sure that the mission does what it's supposed to do. So I coordinate my team. I'm responsible for the managerial things like hiring new people and doing performance assessments. But we also have to coordinate with the rest of the satellites, so the platform engineers. Also the ground segment, our flight operations is in Darmstadt in Germany. Our payload data segment, that's the people who do archiving and processing the data, that's in Italy. And then we have a whole separate Japanese ground segment. We have difficult telecom timings because of that. Scientists, big user community, basically across the whole world. Sometimes we have to break bad news to them, and that's usually my job. Not so great all the time, but okay, someone has to do it. Then, of course, there's all the standard parts of any big industry like HR and marketing. But for ESA in particular, we have to interface with the delegates from each country to justify how we're spending the money, because it's the money from the different nations that are making part of European Space Agency. I do a lot of meetings and participation to tests at industrial sites, of course. I used to do a lot more of simulation and modeling and preparing technical reports. Now I tend to be asking other people to do them, but I still need to be able to understand those technical reports. And for me, I'm more of a generalist, a system engineer across a wide variety of expertises, and I have to give presentations. Eventually, I hope I get to the launch campaign, of course. The next slide, please. There was already a question in the questions and answers, so I wanted to say something about that actually, because people think aerospace you have to be an engineering or a physicist, but you don't. We have biologists, we have a lot of on-orbit experiments that go up to space station, we have biologists and animal specialists as well, we have mice going up to space, we have a lot of medical specialists. Medical science, aerospace medicine is a whole branch of medicine. We need physiologists, psychologists. You're going to stick people in a tin can and expect them to still function after several months. We have a lot of trainers, including scuba divers that have to train astronauts. There's a whole branches of law, the space law, contract law, of course. We have a lot of space treaties, international treaties, all the normal financial aspects. Flight operations, it's kind of like aircraft control, but it's controlling satellites. So we have to have a lot of operators, even down to interior designers. You have to design those tin cans that are space stations or on the moon. They have to be designed in a way that people can be trapped in them in close proximity with other people and not go insane being there for many months at a time. It's a very important job. And there's product assurance, of course, and all the standard parts that you'd see down to HRZ. And the next slide, please. So my tips would be to be proactive in whatever you do. So actually really go and look for the opportunities and take advantage of them. But be adaptable, because things won't always go like you want them to. I didn't get to be an astronaut. UK wasn't participating in manned spaceflight when I was younger, and now I have kids and I'm not going to leave them. So don't just be single-minded about one thing, but be ready to change your mind and be happy in other things too. Make use of help where it is. Prepare yourself. Don't just think you can wing an interview or an exam or any opportunity. Really make sure you're prepared. It shows. Try and get some work experience. It doesn't have to be in the engineering field to be an engineer. Just the fact that you can solve problems, that you can work in a team, that you've actually gone out and got a job. It's really will be good for you and for demonstrating your capabilities. You don't actually need to be an extrovert. I certainly am not an extrovert, but you do need to be able to show that you can communicate with other people. And then there's enjoy life. I mean, all those other things, all of the horse riding, the ballet, the sailing, and whatever it is that tickles your fancy. Make sure to enjoy life and don't follow a career just because you think other people think you should do it. Make sure it's something you enjoy, because you will spend very many hours probably doing whatever it is. And on the final slide, I just put some links that might be interesting to people for various things that I did anyway. Thanks very much for listening, and if you have any questions, I hope I can answer them later.
I'm just going to take over because we're having some technical issues. I hope everyone can hear me. And I just want to thank Kotska for her amazing talk and some of the amazing images, and especially those last few slides where you showed like the sheer range of roles that exist in the kind of world of, I suppose, space technology and exploration. I think that's something that a lot of us we need to be kind of reminded of, that there's so many different people working in that kind of area of life. And I'd just like to echo what you said about work experience. I think a lot of people they don't think it's worth doing unless it's exactly the niche area that they want to go into, but it has just such a lot of general value as well. So thank you, Kotska, and I'm now going to hand over to Faye, who is a Professor of Theoretical Physics at Imperial College London. Welcome, Faye.
Thank you. It's a real pleasure to be here. It's absolutely fascinating hearing the other talks. So I have lots of questions myself. Oh, can you go back? That's for later, the picture. Yeah, great. Thank you. So I've been asked to tell a little bit about my time at Manchester High, and I really attribute my career really to the teachers that I had there. So I work in theoretical physics, that's true. It's very mathematical, so I use maths a lot. And when I was at school, I loved maths above all other things, partly because I had fantastic maths teachers at Manchester High, and I am so grateful to them for the way that they taught me, they encouraged me, they expected so much, and they were very exacting. they weren't kind if you didn't try hard. So, but I totally appreciated them all, and yeah, I pay tribute to them and thank them for everything they did. And I wasn't interested in physics at school, although I was also taught by Jen Scarsbrook, who I agree was an excellent teacher, but I just like maths. I did double maths and physics for my A-levels, and if there had been triple maths, I think I would have done that. So I was pretty, monomaniacal about what I was interested in doing. I like to do sums, and I just wanted to do more sums. So I went to university to do maths, obviously. I went to Cambridge, and there I kind of had the stuffing knocked out of me a little bit. I arrived super, super confident. I could do anything. My teachers at Manchester High had, sort of basically treated me as if the sky's the limit. And I got to Cambridge and I thought, oh, it's actually really hard. And then things changed in my third year at university. I took a course in theoretical physics about Einstein's theory of gravity, which is called general relativity. And I loved it. And I thought, this is so interesting. I just want to know more about this. This is it. This is the thing that I want to learn about. And that feeling has never gone away. So it's sustained me my whole career. I still love gravity. And Einstein's theory of gravity is a theory of space and time, as well as gravity, which is what makes it so interesting and fascinating. So I decided I had to just stay on and learn more about this. And so I did a master's course also at Cambridge, and I applied to do a PhD also at Cambridge, which I did, and I had the luck to have Stephen Hawking as my PhD advisor. And through him, I became interested in the question of what the deeper structure of space-time is, even deeper than what general relativity and Einstein's theory tells us. And in particular, what the quantum structure of space-time is. So those are the questions that Stephen was exploring and studying and doing research on when I joined him as a PhD student. And at the time, it is that quest to find this quantum structure of space-time is an international endeavor. There are scientists all over the world who are engaged in this effort, and but it was much smaller then. Now there are many more people interested in this area, and I have many colleagues all over the world. It's a very international activity, and I'll show you the slides of where I've worked, and that's one of the joys of it. So the colleagues that I have here where I work at Imperial College in London are from all over the world, and I can work with my colleagues in India and colleagues in Canada, and I really appreciate that aspect of my job. So after I finished my PhD, which was on space-time wormholes, I got my first job as a postdoctoral research associate at Fermi National Accelerator Laboratory. So if I can have the slide. So this is Wilson Hall, which is the main building. Fermi National Accelerator is in Batavia, Illinois. It's near Chicago. And the main accelerator ring they have there is for studying the structure of matter at its most basic level. And the main experiment is called the Tevatron. They accelerated protons and antiprotons together. You can just see behind the hall there's a sort of circular, looks like a canal. So that's a circle. That's the main Tevatron ring. So they accelerate protons one way and antiprotons the other way around this ring, and then they allow them to collide, and they study what comes out. And I worked in the astrophysics. I wasn't a particle physicist. I worked in the astrophysics group, and I was studying quantum cosmology. So what the consequences of the universe being quantum mechanical would have for our understanding of cosmology, which is the study of the universe on the largest possible scales. And I have to say it was enormous fun looking for these photographs for this. I haven't done nearly as good a job at producing these slides as our other two wonderful speakers, but I did enjoy taking a trip down memory lane, remembering working in these places. So I used to, it snowed a lot in Chicago in the winter, so I would often park my car in the driving snow and then walk into Wilson Hall to get to my office. And can I have the next slide? So after 3 years of working at Fermilab, I got a job, another postdoc, in the relativity group. So relativity means gravity. The gravity group in the physics department of University of California, Santa Barbara. This is the building, the physics building, Broider Hall. And I think Santa Barbara could have a good claim to be the most beautiful university campus in the world. It's in Southern California on the Pacific Ocean. There are mountains behind it. There are these islands just off the coast, and you can see, if you're lucky, see whales in the ocean from the top floor of Broider Hall. So it's, yeah, absolutely a gorgeous place to work. And I was still working on quantum cosmology. I started to think more about black holes and the quantum aspects of black hole physics while I was at Santa Barbara. Next slide, please. After that, I moved to just down the road, actually, to California Institute of Technology, or Caltech, which is in Pasadena. It's very close to Los Angeles. And I worked there for a year, and I was still pursuing my studies of black holes while I was at Caltech. And it's, again, a very lovely campus, as you can see there. Next slide. And then I got a 5-year postdoc. So the other jobs are relatively short, just two or 3 years, or 1 year. But then I got a 5-year fellowship to carry on my work on quantum gravity, on black holes. and quantum cosmology in Imperial College in the theoretical physics group, and that's a picture of the building that that my office was in, the Huxley building. Next slide. Then after that, I got a job as a lecturer. So this was a permanent academic position at Queen Mary. The physics department is the G.O. Jones Physics Building, which you can see there on the left, and the magnificent building on the right is the it used to be called the People's Palace, and that's the foundation. Queen Mary is a very interesting history. So it was set up as a place of learning for working people in the east of London. And then next slide. And now after that, I came back to Imperial. I've been here since 2003, and that's an overview of the whole campus. And it's in a really lovely part of London. It's by the Science Museum and the Royal Albert Hall and the Natural History Museum. So I feel very lucky to work here, just physically as a place to work. It's very, very magnificent. So I'm still in love with gravity. I still find the question of what the quantum structure of space-time is drives me and motivates me. But I don't do it all the time, because being an academic in a university is not all research. So I would say that about 40% of the time I'm doing research, 40% of the time I'm doing teaching and preparing for teaching. And the rest of the time is administration and other sorts of things. So for example, I spent most of today writing a grant proposal. So I'm applying for funding to hire a young postdoctoral research associate, the sort of person that I used to be, someone to come and work with me on this research. So I'm also very happy in my career. I feel still able to contribute to this area, and I'm glad that I'm able to contribute. I love teaching. I feel a wonderful part of my job is to interact with students, to pass on my love of my subject to them, and also I appreciate and enjoy being part of young people's lives at a very formative point in their lives when they're just leaving home, coming to university. It's a joy to get to know students and to teach them and mentor them. So there isn't as was said before, that there's no typical day. So today, I don't typically spend the whole day writing grant proposals, but today just happened to be that because the grant deadline is coming up. So it's all mad rush to get. I'm going to be doing that again after this evening's meeting. But yeah, I'm super happy in my job, and I appreciate all the aspects of it. So, and I'll end there. Thank you.
Thank you so much, Faye, for your account of a career in academia and some of the amazing places it's taken you as well. Certainly California looks quite appealing at the moment, just looking out at the dark and the rain. Thank you very much. So we've got some questions coming in, and I will look at those in a moment. At this point in the evening, I normally look at a few courses. So I've actually singled out a couple of degree courses, more traditional degree courses, and a degree apprenticeship. So I'm just going to talk about these briefly to give you an idea of, because obviously there's such a huge range of scientific degrees out there, it's quite overwhelming. So I usually pick a couple that are contrasting really. So I've picked a degree in biomedical sciences at Edinburgh, When I first came to Manchester High, I actually, in my ignorance, I thought that biomedical sciences was just what people put as a fifth choice on their medical school applications, and I'm quite ashamed. But it is, you know, it's a really valuable degree in its own right. I picked Edinburgh because it's part of the university, the Edinburgh Medical School, which is actually one of the oldest in the country. It dates back to 1726. And it's interesting. I picked a Scottish one because it's 4 years, and the fourth year, the final year, features a big kind of research project. I also thought it was an interesting faculty at Edinburgh because there are actually 7 distinct degrees within biomedical sciences. One of which is infectious diseases, which obviously seems particularly relevant during a pandemic, or the final stages of the pandemic, hopefully. There's also degrees in anatomy and reproductive biology, anatomy and development. So you can specialise, or you can keep it broad. But my biomedical sciences is basically the scientific basis of medicine without worrying about actually, you know, applying it to real life patients. So it's a popular degree for people who are interested in maybe a career in the pharmaceutical industry or in public health, which is something else which has been obviously, or vaccine research, things which have been very much in the news recently. Surprisingly generous entry requirements, I thought. So they asked for AAB. And if you've done A-levels rather than Scottish Highers, you can actually go in second year, which makes it start in the second year, which makes it a 3-year degree. So I thought that was quite interesting as well. I suppose just to echo what Sujata was saying, there's a huge range out there. So you've got your really quite broad degrees like natural sciences, where you can kind of drop bits as you go along, but you might study everything in the first year, or you've got more specific courses like infectious diseases and so on. So that's my first degree. Can I have the next slide, please, Lex? Now, this I picked this one accidentally, and then it did actually come to me that was almost Sujata's degree. Yours was the 4-year one, wasn't it? And it came back to me that you'd gone to, I remember that you'd gone to somewhere else and then come back to Manchester. So I picked it's a pretty prestigious degree at Manchester, it really is. So physics with astrophysics. The entry requirements are really high, A star, A. The contextual offer is only very slightly lower, A star, AA, so it's not a big concession really. And last autumn, they had 1,800 applicants for only 330 places. It's ranked first in England for physics and astrophysics, and the department boasts of being associated with, I think, 13 Nobel Prize winners, I think it was, possibly, a large number anyway. It has an interesting career section where it talks about graduates from this degree and where they end up. A lot go into research, obviously like Sujata did, into other science-related careers and industry, and other seemingly unrelated careers like finance. So that's Manchester, and you obviously have to have physics and maths at A-level for that one, and biology and chemistry for the Edinburgh course. Can I have the next slide, please, Lex? So I was going to talk a little bit about work experience, but Kotska has really said what I wanted to say, which is do some work experience. It's all really valuable and worthwhile. It doesn't matter if it's not exactly in the field that you're hoping to work in the future. If you have a look at some of the websites for these really big scientific companies, these big, pharmaceutical companies, you'll often find, graduate schemes, internships, work experience schemes. They can be quite hard to navigate round, and a lot of them aren't really interested in you until you're actually studying at university. But it's certainly worth having a look at organisations like GlaxoSmithKline and so on. Obviously, they're international, so make sure you're looking at the UK opportunities. They do also offer apprenticeships, but the one I've selected, can we have the last slide, Lex? Is something a little bit different, which I found. The National Nuclear Laboratory, which is a government-run organisation, I believe, offer a level 6 degree apprenticeship, which means that they will pay for you to study and get your degree. They offer a scientific apprenticeship, which means you come out with a degree in chemistry. You'd also be working for them, and you'd be based either at Preston or Sellafield. I imagine this would be fairly intense because you work 4 days and have a single day release to go off and study. So it takes you a little bit longer to get your degree, but obviously you're not having the student debt, and you're getting a lot of work experience along the way. It also mentions a competitive salary, but doesn't actually say how much it is, which was a bit disappointing. But I suppose the most important thing is that they're going to pay your tuition fees. What I would say about the degree apprenticeships is that they're definitely worth looking at, but it does mean that you're kind of made to specialise a little bit sooner than you may want to. So you do need to be sure, if you want to keep your options open in terms of a career, it might not be the ideal path for you, but there are more and more of these every year, and they're worth looking at. So that brings me to the end of my section, and I'm just going to have a look at the questions that have come in and see if any seem particularly appropriate. Some of them have been answered already. Now, there's one here about studying medicine and still being able to work in the space sector. So if I can direct that to Kotska, you did mention that. I'm just wondering, do many people go through all the hard work of qualifying as a doctor and then move into the space sector?
Many people, what's many, I guess there are many doctors out there, and only a few of them are specializing into space medicine, but it is absolutely a field. We have the astronaut center at Cologne, and space medicine is followed quite closely there, but also at ESA we have the human and robotics directorate, a whole directorate, and astronauts are going to keep going, and commercial astronauts will be going. We have to make sure that they can survive the missions. There are all sorts of things. I learned more about it at International Space University, all sorts of effects on the body. You know, when you stand up on Earth, you know that you're standing straight and you're sitting in front of a laptop. Astronauts have no conception of that. They actually they fall forward, and if you tell an astronaut to stand straight in space, they're bent. They don't know, but they, you know, you discover this through space medicine. So yeah, it's a field. There's lots of biological stuff as well. Yeah, it's a definite pursuit.
Okay, thank you. Here's one for Faye. So we've got a kind of question here. You've all achieved so much. Was there a moment when you felt that you'd made it, or is it a never-ending journey? Is it more organic, or did you feel that there was a kind of a peak or a summit, I suppose, in terms of your career path?
There are ups and downs. I mentioned that I had a bit of a crisis of confidence when I was an undergraduate. I think things changed for me. I think during my time when I got my first, a big break obviously was having the opportunity to study with Stephen. So I was incredibly lucky for that. And then the second luck was the second kind of big thing that happened was I got a permanent position, a so-called lectureship. So I didn't have to continue to apply for these temporary postdoc positions anymore. And that gives you a lot of, it frees you because now, because you don't have to keep applying, you can think more long term about the problems that you're working on. And I decided at that point to pursue a particular direction in quantum gravity research, which is it's based on the idea that space-time is fundamentally granular, that in Einstein's general relativity, space-time is smooth. It's a fabric that's smooth and continuous. But my colleagues and I are pursuing the idea that that's just an approximation to what's really going on, which is that space-time is granular, it's bitty, it's pixelated at the fundamental level. So, and I made that decision, and not many people were working on it then. Some more, so the numbers have grown, but very slowly. It's still a small area, a small approach within the whole field of quantum gravity research. But that made a huge difference to me, because I felt that I was really doing something worthwhile that I could contribute to in a major way, rather than being sort of doing something which lots of other people were doing. I felt that this was valuable because not many people were doing it, and that it's good to have a diverse approach to a problem as difficult as quantum gravity, because you don't know what the right answer is going to be. So you should have different ideas and different approaches. So that since then, I've just been the happiest I've ever been in my research. I get happier and happier, actually. So I welcomed a new PhD student a couple of days ago. He's come to work with me from Iran, and it was such a joy to see him. And I feel so happy to be able to know that I can teach him and train him, and that he'll become part of this this endeavor. So yeah, key moments, yep. Getting the PhD position with Stephen, getting my first lectureship, and then making this transition to this field, which I feel is my scientific home. I'm going to work on this till I die. I think that's, you know, some academics say they're looking forward to retirement because then they can really get some work done, because all the other aspects of their job sort of get in the way of doing their research. So, but yeah, I feel like I know what I want to do, and I'm gonna do it forever.
Okay, thank you. Sujata, I'm just going to ask you the last question, or it's kind of two questions kind of clumped together, about A-level choices, because this is something I always get asked. Firstly, did you do further maths? Because I couldn't remember from your slide.
I did and didn't.
Okay.
Mostly I didn't. I did do one module. I think it was FP2, if I remember correctly. And I wouldn't say that it greatly impacted my, at least my university education afterwards. I think maths would have been sufficient, at least for an undergraduate or an undergraduate master's at Manchester. That being said, had I done it, I may have had a totally different experience. I definitely never really struggled with the maths at university, but it did become increasingly abstract, which perhaps that's something they teach in further maths. Okay. But if your question is whether it needs to be done to do a physics degree, probably not.
Okay, that's useful. Okay, and did you find your languages useful?
Well, interestingly enough, I did. When I selected Latin, and very much a reason that I don't want to use the word excuse, but a reason that I gave my parents for why I was selecting it was be really useful if I ever want to go into medicine, because Latin is obviously the basis of a lot of medical terminology. But I would say more than anything, it just offered me a balance outside of very scientific kind of tunnel vision view, because you do learn different skills as a language student at any level, I think, not least to just not be identified totally as a nerd, I think. But yeah, I really enjoyed Latin and French, actually, for that matter. And yeah, I think the type of analytical thinking you have as a scientist is very nicely balanced by the type of skills you learn, kind of interpretation, body language as well, that you don't necessarily realize you're learning, but you do learn as a language student as well. So yeah, I wouldn't say avoid it. If you've got a spare A-level choice, then I would definitely say consider a language.
Okay, thank you. Okay, I think that brings us to the end of tonight's talk. So I'd just like to thank our three speakers again for joining us and sharing their amazing, varied and really quite kind of intense and unique career experiences and kind of educational and career journeys. So thank you to Sujata and Kotska and to Faye. Our next talk is in early December. I think it is the 2nd of December, and it is about careers in the digital tech industry. So do look out for the posters going up around school and social media and so on. And we hope you enjoyed tonight and found it useful, and that you will join us again in December. Thank you very much, everyone.